In this class, let us discuss about NOR gate SR latch. S means set, or means reset. Latch is used to store a temporary data. Okay, na? So SR latch implementing by using NOR gate. Here G1 is the NOR gate, G2 is the NOR gate. Okay, na? So G1 output is given to input of G2, and G2 output is given to input of G1. This is called cross coupled. So two NOR gates are cross coupled with each other. Okay, na? S means set means 1, reset means 0. Okay. Now, so this is example of a sequential circuit. It is example of a sequential circuit. So sequential circuit is nothing but, so the output depends on the output depends on the present inputs as well as past output. Okay, na? Actually this is a present output, it is also a present output, but this present output is given to input of, present output is given to input of, right, this present output is given to input of G2, that is Q. This present output Q bar is connected to input of Q1, Q bar. Okay, na? Now R and S are the present inputs, Q and Q bar are the past outputs. So present inputs and past output, then the output is generated is called the next state Qn plus 1. So S is the input, R is the input, Qn is the past input. Okay, now this is a, so I'm writing Qn bar. So this is a Qn bar, Qn. So this is a, these two are the past outputs. Okay, now R and S are the present input, Qn bar are called the past output. So after giving input, and one of the input is present input, another input of the G1 and G2 are the past output. Qn bar are the past output. So okay, so then only you are going to get next state Q1. Simple. S and R the present inputs. Q, so for simplicity I am considering only Qn, I am not considering Qn bar, because so Qn and Qn bar are the cross coupled with each other. So if Qn equal to 0, automatically Qn bar will become 1. This is nothing but complemented with each other. That's why we need not take Qn bar, only Qn is considered. Okay, now that's why I've taken only Qn, and Qn plus 1 is the next state output. Okay, now so should remember very clearly, otherwise you will get confused, right? This is a SR latch. So S and R are the present inputs, and Q and Qn, so instead of Q I am writing, instead of Q I'm writing, just understanding Qn and Qn bar. Q and Qn bar are the present outputs, but this present output is given to input of NOR gate. This Qn bar is a present output which is given to input of this Qn bar is given to input of G1. Okay, na? But these are the present outputs, but they are given back to the input of gate. No, that's why it is called past output. So R and S are the present inputs, Q and Qn bar are the past output. So after giving present input and past output, the NOR gate will produce the next state. Final output is called Qn plus 1. Okay, that is about inputs. Okay, na? Right. So this Q is connected to the output of G1 is connected to the input of G2, and output of G2 is connected to the input of G1. Okay, na? So that's why these two are called as cross coupled. Okay, let me concentrate on the truth table. So S is the present input, R is the present input, Qn is the past output. Actually it's the present input, but which is given to input of G2. No, that's why we are calling past output. We need not consider Qn bar. If Qn equals 0, Qn bar will become 1. Okay, na? So after two present inputs and one past output, so it is going to produce the next state output, that is called Qn plus 1. It is the next state. So Qn is the present state, Qn plus 1 is the next state. Okay, na? Right. So now in order to analyze this truth table, so we should understand about first truth table of a NOR gate. Then only you will understand that this truth table very clearly. That's why I'm writing truth table. So S R. Okay, na? So 0 0 0 1 1 0 1 1. Clear? Now so S plus R, NOR gate, no, A plus B bar. If AB is the input, A plus B bar is the output of the NOR gate. No, similarly I wrote here SR, because here in this NOR gate we are giving S is the input, R is the input, right? Now NOR gate, no, so when both inputs are 0, output is high, remaining all the cases output is 0. Okay, now this is about NOR gate output. Clear? Okay, let us discuss here. So I am giving first s equal 0, r equal 0. So right, I am giving s equal 0, r equal to 0. Now I am giving s equal to 0, r equal to 0, right? So s equal to 0 means, so I am giving 0 here, r equal to 0, I am giving 0 here. Okay, but this NOR gate G1 has only one input. NOR gate G1 has only one input. Okay, na? But in order to produce Q1 output, I should know another input of G1. I should know another input of G1, but I don't know this Q bar. Okay, na? I don't know this output, present output. Okay, na? So it required two inputs. No, one of the input is R, and I don't know about previous past output. I don't know. That's why past output I am taking as Q1, Qn. Qn is the past output. Okay, na? So I am giving 0 0, but I am assuming whenever my past output is 0, what is my next state? Similarly, I am giving 0 0 again. If my past output is 1, then what is my next state? Okay, na? So 0 0 I am giving in both cases. First, I don't know about the past output. That's why I'm considering as a past output. I'm assuming as 0 at one time, and again same input 0 0 SR I am giving. I'm taking past input is 1. Okay, na? So in this case, because I don't know, I cannot determine initially what is a Qn state and what is a Qn bar state. I don't know about the past output. I know only SR inputs only, but I don't know the past output. That's why I'm assuming. So input 0 0 along with if my past output is 0, what is my next state? And if I'm giving 0 0 as my input, if my past output is 1, what is the next state? Okay, na? That's why I wrote here. Okay, na? Right. Okay. Now look at here. Now I'm taking 0 0 as my first input, and if the past output is 0, I'm assuming if my past output is 0, what is my next state? Okay, look at here. So s equal to 0 and r equal to 0. So here r equal to 0, I don't know previous output, so that's why I'm taking, if my past output is 0, what is my next state? Okay, now right. Now look at here. So r equal to 0, if I'm assuming my this is 0, this 0 is Qn is 0, so 0 is coming here. Clear? No? So this 0 is coming here. Now what is the s 0 0? Okay, na? One of the input is s, another 0. So 0 0 I am giving here. What is that? I am giving 0 0 here. So 0 0. When I am giving 0 0, so this input is receiving 0. Another input is receiving, because I assumed the previous output is 0. So this 0 is coming here. Now present input is 0 and my past output I'm assuming 0. When both are 0 0, what is my NOR gate output? 1. So here 1 is coming. So this 1 is given to input of this, no? This 1 is coming here. Now what is my present input for this? So r equal 0, s equal to, so r equal 0, my past output is 1. Now 0 1. 0 1 means what is my next state? 0 only. Okay, now I got next state 0. Okay, now similarly I am going for another input. So same 0 0 I am giving, but my past output I'm assuming as 1. Previously just now I assumed my past output is 0. So I am going to assume now my past output is 1. In that case, what is going to be happen? Okay, na? So this is very important. So because we don't know the past output, initially the Qn I am assuming 0 at one time along with the 0 0 input. Again I am giving, okay, na? Now so now 0 0 I am taking by, but previously I assumed my past input is 0. Now same inputs I am assuming my past output is 1. If my past output is 1, okay, r equal 0, s equal 0, no? R equal 0, s equal 0. My past output Qn equal to 1. This Qn is coming here. So 1 is coming here. So 1 0. When I am giving 1 0, what is my output? 0. Now the output is 0 here. So this 0 is going here. Now both are 0 0. Okay, na? Both are 0 0 0 0. So 0 0. What is my output? 1. Now next state I am getting 1. So what did you understand? So input is 0 0. My previous output is 0. My next output is also 0. Previous input 0 0. I'm assuming my past output is 1. My next state output is also 1. Okay, na? So I can say that, so the next state output is same as the previous state output only. That's why it is called as a no change state. Present output, next state output is same as the previous state output or past output. Okay, na? That's why this state is called no change state. Okay, no change means present next state, this present state and previous state both are same. That's why it is called as a next no change state. No change means so present output is same as the previous output, no change in that. Okay, na? Let us take another example here. We'll understand. Now I am giving now next state. Okay, 0 1 as my input. So s equal to 0, r equal to 1. So as usually I don't know about my previous state qn. That's why qn I'm assuming 0. So this 0 is coming here. Now both are 0 0. What is my output? 1. So it can produce a 1 as my output. Okay, now this 1 is going to input of this. Now both are 1 1. When both are 1 1, what is my output? 0. Now I got out my output is next is output is 0. Okay, now next. Similarly, I am taking same another example. I am taking another example. So my s equal to 0, r equal to 1. So s equal to 0, r equal to 1. These are called the present inputs. These are called the present inputs. As usually, I am assuming my previous or past output is 1. Okay, now my past output is 1. Now I am taking here, I am considering here my past. Previously, I assumed past output is 0. No, now I am assuming my past output is 1. Now this 1 is coming here. So this one is coming here, right? This one is coming here, yes or not? Okay, na? So now 0 1. So 0 1, what is my output? 0. Now it is producing 0. So this 0 is going to input of this 0 here. Now 1 0. Now 1 0 is here. No, 1 0 means 0. That's why I got my output. Another output is also 0. Okay, what is it? What does it mean? So look at here. Whenever I am giving, sorry. Yes, whenever I am giving, okay, my inputs, my input is 0 1 0 1, but I assume previous output is 0. I don't know, and again same 0 1. I assume my previous output is 1. 0 1 are the present inputs. Okay, na? And one initially I'm assuming my past output is 0. What is my next state? And my past output is 1. What is my next state? So now I got my next state is both are 0 0. Independent of the previous state. This is a past state, this is a present state. Okay, na? So I got my next state is a present state 0 0 independent of the previous output. That's why it is called as a reset. Reset means 0 0. No, reset means 0 0. Okay, na? That's why I got in this state I got reset. Okay, na? Next I'm going to analyze another input. Okay, na? So my past output is my next state output I got 0 independent of the previous output or past output. I got next state 0 0 independent of the previous. My previous state may be 0 or 1, but next state I am going to get 0 0 only. That is called reset. Okay, na? I'll take another example 0 0 0 1. Yeah. Next, let me take another example. Third example. We are going to see third example. Okay. Now let us take my s equal to 1, r equal to 0, s equal to 1, r equal to 0. As usually, I don't know about the qn. That's why I'm assuming qn is 0. So when I'm giving 0, this 0 is coming here. Now the gate 2 inputs are 0 1. So gate 2 inputs are 1 0. S is 0, s is 1, r is 0. Yes or not? S is 1, r is 0. Now s is 1, r is 0. What is my output? Is produced output is 0. This 0 is going here. Now for this gate 1. So 0 0 0 0 means I got 1. No, that's why I got my output is 1. Next state output is 1. Next, now I am going to talk about. Let me take another example and check what is my output. Okay. Now, so I am taking again s equal to 1, r equal to 0, s equal to 1, r equal to 0 only. But I don't know the previous state. No, but previous case I assumed 0. Now I am assuming my past output is 1. This 1 is coming here. Both are 1 1. No, this gate 2 has inputs 1 1. Whenever 1 1, it produces 0 as my output. So it will produce 0. So this 0 is coming here. Now inputs are 0 0. Whenever input is 0 0, I am going to get my output is 1. So here that is my output is 1. Okay, na? Right. So here, what did you understand? The next state is same as the previous. Sorry, the next I got next state 1 1 independent of the previous state. Now what is my previous state or past state? Past state is 0 1. So independent of past state, I got next state is 1 1. That's why it is called state. State means 1 1. No, so like that, very clear. Next, last state we are going to analyze. Last state we are going to analyze here. Okay, what is the last state? Now 1 1. I'm taking s equal to 1, r equal to 1. Okay, so in this case, so undetermined state will come here, or invalid state is going to come here. Let me check how. Okay, now in s equal to 1, I'm assuming r equal to 1. As usually, I don't know about previous state. I'm assuming 0. So this past output is 0. Now s is what? 1 0. So what is the 1 0? I got 0 as my output. So this 0 is I'm given to input of this. Now 1 0. 1 0 means I got 0. Okay na? So I got again 0 here. Okay na? Right. Here I got 0 is a q bar is status is 0 and q status is 0. It is wrong because if q bar is 1, I should get q equal to 0. So but both are q, I got 0, q bar also I got 0. So actually these output should be in complemented form. Q and q bar must be in the, if q is 0, I should get, I supposed to get q bar is 1, but q bar also I got 0. This is 0, this is 0, right? So q and q bar are the same output, so it is invalid. So you are not supposed to get 0 0 q n. Okay, q n bar, so 1 1. I should not get like this. If I am getting q n equal to 0, I should get q n bar equal to 1. If I am getting q n equal to 1, I should get q by q n bar equal to 0. But here I got 0, here I got 0. That's why this state is invalid. This cross mark indicates don't care, or undetermined, or unpredictable, because both outputs are getting same. No, let us check another input, then you will understand very clearly, right? Now what is my next output? Look at here. So my s equal to 1, r equal to 1. I am giving s equal to 1, again r equal to 1. Previously I assumed my qn equal 0. No, now I am assuming qn equal to 1. So 1 1. So this 1 is coming here. Whenever 1 1, it produces 0 as my output. Now qn bar equal to 0. Now 0 is going here. Now the input is 1 0. The input is 1 0 means I got again 0. Okay na? So qn also I got 0. So qn bar 0 I got, qn also 0 I got. Here also I am getting 0 0. So it is also invalid. If I am getting 0, it has to get 1. No, now both qn and qn bar both are 0 0. It is also invalid state. Now that's why it is invalid state or undetermined state. Okay na? So this is about I think, I hope you understood very clearly about this is a latch. Now I am going to talk about, okay, so these are so far I discussed, but it is, if you even your understanding it, little confused, so I am going to explain how you are, how you have to remember easily. Okay na? So I'll give a trick so that you will understand very clearly. Okay, because s is a present input, r is a present input, right? R is a present input. Okay na? Now I am taking s and r are the present input. S and r are the present input. Clear? Right. So s and r present input, and this qn is coming here. No, qn is coming here. This qn bar is going here. So actually the present output, but they are coming as a input to the gate 2, and this is going to input of gate 1. These are called past output. So past output is again input to the G1. No, this past output is input to the G2. No, that's why I am considering this is also one of the input. Past output became input to the gate 1 and gate 2. Now how many inputs are there? There are 3 inputs. Okay na? Present in these two are S1 present inputs, and Qn is the past output. Now how many variables are there? 3 variables. That's how many combinations will come? 8. 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay na? So first after this is completed, this is completed. No, that will come here. So that will come to the state. So should just remember NRSI. N means no change. No change means present input. No change means present input and past output both are same. Present input or past output both are same. Present input is 0, past output is 0. Present input is 1, past output is 1. That's why it is called no change state. Next, independent of this, we should remember this reset. Reset means 0 0. So independent of the past outputs, I am going to get my next state is what? 0 0 only. Okay na? That's why you should write 0 0. Reset means you should understand 0. Reset means 0 now. And next state is set. Set means 1 1 only. So that's 1 1. So independent of the previous states, I am going to get my next state is 1 1 only. So that's the state. I means invalid. So these are the invalid, no? So XX. Okay na? NRSI. Just remember this. So this is a truth table of RS latch. Thank you very much. Thanks for watching. If you like this video, please subscribe and share it. Okay, thank you very much.